Okay, we're going to look at this problem where we have a parabola f of x equals x squared and another one g of x equal the quantity x minus 4 squared plus 5, and there is one line with a positive slope that is tangent to both of the parabolas at the same time. So here's a little picture to help us visualize. So there's some point on this parabola, we're going to call it x sub 1, y sub 1, such that its tangent line to the curve is also the tangent of some point on this parabola. We'll call that x sub 2, y sub 2. So let's think what we know about it. We know that if we find the derivative of f of x at x sub 1, that is the slope of the tangent line to the curve at that point, and that's going to equal the derivative of g of x at x sub 2, and that's also going to equal the slope of the tangent line that's the same line, and that's the equation of the line we want to find. So let's go ahead and write this down. If we find f prime of x, that's going to be 2x, and if we want to find g prime of x, we can take g of x and we can multiply that out. That's going to be x squared minus 8x plus 16 plus 5, so plus 21. So g prime of x is going to be 2x minus 8. So now what I do know is if I evaluate f prime at x sub 1, so that's 2x sub 1, that's going to equal g prime at x sub 2. So that's going to equal 2x sub 2 minus 8. And I know both of those equal then the slope of the line I'm trying to find the equation of. Okay, so let's actually solve this for x sub 1 so we get a connection between x sub 1 and x sub 2. I'm going to divide everything by 2. So x sub 1 equals x sub 2 minus 4. So that is one connection that we have between the 2 points, the one that's on f of x and the one that's on g of x, where we have the tangent. Now let's see what other connection we have. Well, I could write down an expression for the slope of that line because I have the 2 points on the line. So I'd have m equals the y from the second point, but let's actually write it with in its equation. So that's going to be x sub 2 minus 4 squared plus 5 minus the y from the first point, and that's actually going to be then x sub 1 squared. I'm just plugging each of those in their corresponding functions over x sub 2 minus x sub 1. Okay, so that equals the slope. Now there's a few things that we could actually do to simplify. If you look at this, we had a connection between x1 and x2, and it's right here, x sub 1 equals x2 minus 4. So I could actually replace that with x sub 1, and that's x sub 1 squared, and it cancels with the x sub 1 squared. Okay, I can actually also substitute down here, and basically what's going to happen then is I am going to be able to find the slope. And I'm going to let you finish that part. This is kind of more of a hints video than a copy all of the way. But if you will do substituting there so that you get this all in terms of one of the variables, because we have a connection between them here, you will be able to find the slope for the equation of the line that you want to find. Well, once you find the slope, we know that from this equation, the slope equals 2x sub 1. So you can find the point x sub 1, and once you know the point x sub 1, you can find y sub 1, and so you're going to be able to find the equation of the line, because you will have, we could do y minus the y from the point equals the slope times x minus the x from the point, and then we can go ahead and get that in the form that they asked. So this should be enough help that you should be able to go ahead and finish this problem.